This video has the solutions to lesson 7-4 about fractional equations. The assignment is 7 through 21 odds. A fractional equation is called a rational equation in some textbooks because it's made out of ratios, the word rational, the word ratio. Fractional equations have one or more terms with a variable in the denominator. They are solved in the same way as the equations in 7-3. You can multiply all terms by the LCD, changing it into an equation that has no denominators. Now, often these equations have multiple ways that you could solve them. If the equation is a proportion, then you can use the technique called cross-multiplying that we practiced a few days ago. Sometimes the equations can be simplified enough that you can solve the problem just mentally. The further you go in algebra, the more you build your skill set, giving you different ways to get to an answer. Note, because there is a variable in the denominator, there will be restricted values. If a value is restricted, then make sure you don't include it in your solution to the equation. We didn't have to worry about this in lesson 7-3 because even though we had fractions, we never had a variable in the denominator of a fraction. There were no restrictions. But this time the equations do have a variable in the denominator, and so you need to consider the restrictions to make sure that your algebraic method doesn't produce an answer that actually is restricted. Take a look at number 7. Here's an equation. There's fractions. This is not a proportion because the left side of the equals has two different terms. So you cannot solve this using the cross-multiplying approach. Do you recognize there's a variable in the denominator? There's going to be restricted values. So a good habit is to identify the restrictions right now. You can figure out the restrictions later, but you have to figure them out at some point. Because the letter n is in the denominator, the letter n cannot be equal to 0. That takes care of our first fraction as well as taking care of that last one. 2 times n cannot be 0, therefore n cannot be 0. Now, this problem can be done with our technique about multiplying everything by the LCD. The LCD is 4n. When there's variables in denominators, to find the LCD, you separately consider the numerical coefficient and the variable piece. We practiced this in an earlier lesson. We can multiply all terms by 4n. N over n cancels out. 4 times 6 is 24. In the next spot, the 4 and the 4 cancels out, but the letter n doesn't. So this is negative n times 1, which is minus n. In the last spot, the 4 and the 2 cancel out to a 2. And the letter n and the letter n cancel out completely. We're left with 2 times 8, which is 16. Notice we took a complicated equation with fractions, and we've created this much simpler looking equation. Now 24 subtract 8 makes 16, therefore n has to be equal to 8. Now this was only one way of solving this equation. It worked pretty well, but there's other things you could have done. The original equation was 6n minus 1 over 4 is equal to 8 over 2n. I observe that the last term, 8 over 2, reduces to 4 over n. Then I could subtract 4 over n from both sides, creating 6 over n minus 4 over n, while at the same time adding the 1/4 to the other side, creating this equation. And this makes 2 over n is equal to 1 over 4. Well, 2 out of 8 is equal to 1 out of 4, and so you get n is 8, right? So just an alternative way of doing the same problem. Now question 9. Here we have an equation that has a variable in the denominator, so there's going to be restrictions. To find restrictions, you say that the denominator cannot be equal to 0. And then solve. If you add x to both sides, we get that x cannot be equal to 4. We have to remember that x cannot be equal to 4 in case we actually end up getting x equals 4 later on. If that happens, we need to exclude that answer. Now looking at this equation, we have options of how to solve it. We can do the method with the LCD, or because this is a proportion, there's only one ratio on both sides of the equals, we can use the technique called cross multiplication. I'm going to try the method involving the LCD. The LCD has 5 and has 4 minus x. And I'm going to multiply all terms by that. I tried to leave space in here to do that. We could even multiply the 5 and 4 minus x after the 3 if we need to, whatever you're comfortable with doing. I'm going to put parentheses around the binomial 6 minus x. The 4 minus x and the 4 minus x cancel away. What's left is 5 times 6 makes 30, and 5 times minus x makes minus 5x. Now on the right side of the equals, the 5 and the 5 cross out, and we're left with the 3 times the 4 minus x. 3 times 4 is 12, and 3 times the x is minus 3x. Now I can subtract 12 from both sides, creating 18, and I can add 5x to both sides, creating 2x on the right. 2 times 9 is 18, therefore x is 9. Now compare that to our previously identified restricted value. X can't equal 4. Well, that's okay. We got x equals 9, so we're all right with that. Now, this same problem can be done using the technique we learned about proportions, which a lot of people refer to as cross-multiplying. I'm going to rewrite the problem over here so you see that. 6 minus x over 4 minus x is equal to 3 over 5. There's only one ratio on both sides, so it is a proportion. The product of the extremes is the 5 multiplied to the 6 minus x. And that's equal to the product of the means, which is the 3 multiplied to the 4 minus x. Now compare that to what we had done earlier when we multiplied by the LCD and had done some canceling. Notice that they're the same. So both methods are going to get you to the same conclusion. It's just which one would you rather do? It's your choice. Now number 11, this is a rational equation with a variable in the bottom. So there is going to be a restriction. To find the restriction, you take the denominator that has the variable and say that it cannot be equal to 0. And then solve. X cannot be equal to 2. We have to keep that in mind for later on. Now, how would you like to solve the equation? With the LCD method or with the thing called cross-multiplying? I like cross-multiplying better. Whenever it's possible to use cross-multiplying, that's the method I like. I can put a 1 under here just to help me identify top and bottom. Now, the product of the extremes is 1 times x minus 2. And that's equal to the product of the means, 1 times x plus 5. That's just x minus 2 is equal to x plus 5. Now subtract x from both sides. And we get negative 2 is equal to positive 5. This is one of those special cases where the variable has disappeared in the process of solving, and we end up getting a false statement. The conclusion is no solution. There is no value that can be used in place of the letter x that will make this a true equation. Now number 13. This is a fractional equation that has a variable in the bottom, so there is going to be a restricted value. The denominator that has the variable cannot be equal to 0. Therefore, y cannot be equal to 2. We have to remember that for later on. Now, we can solve this by multiplying everything by the LCD or use the technique called cross-multiplying because it is a proportion. That's the way that I'm going to do. So on one of the diagonals, we have 1 times 2y minus 6. And that's equal to, on the other diagonal, 2 times y minus 2. 2y minus 6 equals 2y minus 4. Subtract 2y from both sides. Getting negative 6 is equal to negative 4. Again, a special situation, the variable is gone and we get a false statement. And so our conclusion is there's no solution. Number 15, there's a variable in the denominator, so there will be restrictions. Take the denominator and say is not equal to 0. Now solve this. Add 6 to both sides and then divide by 4. We get 6 over 4, which reduces to 3 halves, which is 1.5 or 1.5. Now keep this value in mind for later on. Now in number 15, because it is a proportion, we can do the cross-multiplying method. 1 times the 4m minus 6 is equal to 2 times the 3 minus 2m. This is 4m minus 6 is equal to 6 minus 4m. Add 4m to both sides, making 8m minus 6 is equal to 6. Now add 6 to both sides. 8m is equal to 12. Now divide by 8, making 12 over 8. Top and bottom both divide by 4, making 3 halves. Now, look what happened. Our algebra produces the number 3 halves as the answer for m. But earlier we said 3 halves is restricted. We're not allowed to use 3 halves because it would create a 0 in the bottom. We have to exclude that value, and because we have no other potential answers, the answer is no solution. Number 17, there's going to be a restricted value. Y take away 2 is not allowed to be equal to 0, so y is not allowed to be 2. Number 17 is a proportion. We kind of clarify that it is if we take the time to put a 1 underneath the 3. Now we can see there's 1 ratio to the left of the equals and 1 ratio to the right of the equals. My favorite method to solve a proportion is called cross-multiplying. I like that better than the LCD method. So 1 times 3y minus 6 is equal to 3 times y minus 2. This is 3y minus 6 equals 3y minus 6. Now, as I'm writing and as I'm speaking, I can't help but notice the left side is equal to the right side. Maybe you don't notice that yet, but when you start to work on it, eventually you will notice it. We end up getting negative 6 is equal to negative 6. At this point, you've got to notice that this makes a true statement with no variable. So our conclusion is that all real numbers work, except, remember this restricted value, we're not allowed to use 2. So our answer is all real numbers except for 2. Number 19, there's a variable in the denominator, so there will be restricted values. The 3c is not allowed to be equal to 0, and therefore c cannot be equal to 0. That takes care of the restriction for this, and it also handles the restriction for that. Now, remember that c cannot be equal to 0 in case that becomes important later on. Now, to actually solve, because it is a proportion, I'm going to use cross-multiplying. C times 2 plus c is equal to 1 times 3c. c times 2 is 2c. c times c is c squared. And on the right side, we have 3c. This is called a quadratic equation. The highest exponent is 2. Earlier this year, we had quadratic equations, and the method that we use to solve them is to transform them into what's called standard form. Write them in a particular format. We have to get a 0 on the right side. So subtract 3c from both sides. On the left side of the equals, we have c squared and then minus 1c. And that's equal to 0. This is referred to as standard form. The reason that we make standard form is so that we can factor the polynomial. There's a GCF of c. So we get c times c minus 1, and that's equal to 0. Now use the zero product property. Set each factor equal to 0. c is equal to 0, and c minus 1 is equal to 0. Add 1 to both sides and we get c equals 1. Now our algebra method results in two answers. One of them is 0 and one of them is 1. But remember our restriction. c is not allowed to be 0. So what's the final answer? It's just c equals 1. Only that number can be included in the answer. We have to exclude the 0. Now, number 21. There is a variable in the denominator, so we have to consider restrictions. One denominator is 2a plus 1. That's not allowed to equal to 0. Subtract 1 from both sides, making negative 1, and then divide by 2 on both sides, getting negative 1/2. Now the other denominator, 2a minus 1, that can't be 0. Add 1 to both sides, and then divide by 2. We discover we have two restricted values. Later on, we have to pay attention to this to make sure that the answer that we get from our algebra work doesn't result in negative 1/2 or positive 1/2. Now let's solve the equation, which once again is a proportion. Not all equations are proportions, but when they are, you can use the method called cross multiplying. So 3 times 2a minus 1 is equal to 3 times 2a plus 1. Now you could do some distributive property here, or you could even notice that you can divide both sides by 3. The further you get in algebra, the more techniques you have available to you. Now, will 2a minus 1 ever be equal to 2a plus 1? Is that possible? If you don't notice that this is a false statement yet, you're going to notice in the next step, take away 2a, take away 2a, minus 1 is equal to positive 1. This is a false statement. What this means is there's no numbers that you could ever put in for the letter a and ever make the left side be equal to the right side. So the answer is no solution.